This video is going to discuss solving two-step and multi-step equations. If you've watched the previous two videos I've made, which have dealt with solving equations using addition or subtraction and then multiplication or division, this is going to be a combination of those videos, because now our equations have progressed to the point where a single step is no longer good enough to solve them. We are going to have to do at least two, possibly more, in order to get our variable alone and figure out what our answer should be. So let's jump right into this and see what we can do. For our first example, we have negative 4 plus 7x equals 3. We should notice that not only is multiplication happening, but there is also addition happening. So our goal is going to have to be to get x all by itself. And to do this, we sort of have to do things in reverse order from what we would normally do. If I knew what x is, let's say x was, if we thought it was 2, and I had negative 4 plus 7 times 2 equals 3. Well, to solve all of this, order of operations would tell me I have to multiply first and then add. Well, if I'm looking for a variable, though, I can't follow the order of operations. I actually have to follow them in reverse, because since the last thing we would do would be add, we have to do that first. We have to undo that first, I should say. So, when we are trying to solve a multi-step equation, the first thing we have to do is get rid of any constants that are only using addition or subtraction. So first thing I'm going to do is try to get rid of this negative 4. And remember from the first video on this, if I have a negative 4, the way to get rid of it is by adding 4 to it. And if I add 4 to one side, I have to add 4 to the second side. So this will cancel out because negative 4 plus 4 is 0. I'm left with 7x on my left side, and then that is going to equal 3 plus 4, which is 7. Now, I've made it better, but I still have one more step I'm going to have to do. I need to get x all by itself. And this should look very similar to an example that we did when we were talking about solving equations with multiplication or division. I am multiplying 7 times x. So if I want to get x by itself, I have to do the inverse operation, which is division. So I'm going to divide both sides by 7. Now, 7 divided by 7 is 1, so I have 1x on the left side, and on the right side, 7 divided by 7 is 1. So we end up with x equaling 1. And that is possibly our solution, but it was important to check our work with single-step equations. It's even more important to check them with multiple-step equations. So we have negative 4 plus 7 times 1 equals 3. And now that we have what the variable was, we need to follow our order of operations. I'm going to have to multiply first. 7 times 1 is 7. So I have negative 4 plus 7 equaling 3. And now I add my negative 4 and my 7. And if I add negative 4 and 7, I end up with 3. So I have 3 equaling 3. My answer checks out. So the solution to this problem was x equals 1. Alright, let's try another example of a multiple step equation. For our second example here, we have n divided by 7 plus 2 equals 6. Notice we have division happening and we have addition happening. So, just like before, I need to get rid of my constant first. My constant is a plus 2. So to get rid of that, I use the inverse of addition, which is subtraction. So I'm going to subtract 2 from both sides. These cancel out because 2 minus 2 is 0. On the left side, we're left with n divided by 7, and on the right side, we're left with 4. Now, we need to get the n all by itself. We've got the variable term isolated, but we need to get the variable itself isolated. And remember, when we're dividing, if it looks like a fraction, we are going to multiply both sides by the denominator. If I multiply by 7 and divide by 7, it is the same as just 1. So we have n on the left side, and knowing my multiplication facts, 4 times 7 is 28. So there is our possible answer. Now it is time to check our work. So I substitute 28 in for n. We get 28 divided by 7 plus 2 equals 6. This time, since I'm trying to actually solve it, I have to follow my order of operations, so I have to divide first. 28 divided by 7 is 4. 4 plus 2, we hope equals 6, and what do you know? Yes, 6 equals 6, so our solution checks out. N is 28. Now these are both examples we've done so far have been two-step equations, but you could have multiple steps depending on how the problem is written. So let's try one that is going to involve more than 2 steps this time and see how we do it. So for this third example, we have 3 times the quantity x minus 4 equals negative 3. We have a couple different ways we could solve this. One would be involving the distributive method, distributing the 3 inside our parentheses and then trying to solve that way. And the other way would be by getting rid of what's outside the parentheses first. Either way will get you the same answer. It just depends on what your level of comfort with the distributive property is. I am going to use the distributive property so that we can model how it would work that way. So let's get started. I'm going to distribute the 3 by multiplying it inside the parentheses against the x and against the negative 4. So when I multiply, I have 3x minus 12 equals negative 3. That was my first step. I had to distribute. My next step is going to look very similar to the examples from before. I need to get rid of the constant so that the only term left is the term with the variable. Since I am subtracting 12, I'm going to have to add 12 to both sides. Negative 12 plus 12 is 0, so those cancel out and we're left with 3x. Negative 3 plus 12 turns out to be a positive 9. So we have 3x equals 9. That was our second step. And now for our final step, we are going to have to get the x term all by itself. So we are going to divide by 3. 3 divided by 3 is 1. So I have x left all by its lonesome on the left. And 9 divided by 3 is 3. So our solution appears as though it's going to be x equals 3. But remember, we need to check our work. So we have 3 times, and I'm going to substitute 3 in for x, so 3 minus 4 equals negative 3. Now, we could distribute here, but since there's nothing unknown in the parentheses, we should follow our order of operations and solve what's in the parentheses first. We have 3 minus 4, which is a negative 1. So we're going to have 3 times negative 1 equals negative 3. And if I multiply 3 by that negative 1, wouldn't you know it, I end up with negative 3 equaling negative 3. So it works out. We've checked our answer and everything is good. Let's do one more, which uses one other special type of scenario that we need to be able to take advantage of and solve correctly. So one more example, and then that's it for this video. Alright, our final example here is 2 times a plus 2 minus 8 times a equals 8. Notice that what's different here is the fact that we have an a on one term and an a on a second term. So before we can try to solve for what a needs to equal, we're going to have to combine like terms. I can combine 2a with negative 8a because they are like terms. They both have the variable a. So my first step is going to be simplifying the expression by combining like terms, and 2a minus 8a is negative 6a. Then don't forget your plus 2 from before, and this equals 8. Now that we have simplified the expression, just like the other examples, we need to get rid of this constant term. And since we're adding 2, we are going to subtract 2 from both sides. That cancels out our constant term, and we have negative 6a equals 6 now. That's a bad equals sign. Let me fix that. So negative 6a equals 6. Now our final step, so that we have our variable all by itself, we are going to divide by negative 6. It's important that we divide by negative 6 because if we only divided by 6, we'd be left with a negative a, and we don't want a negative a, we just want what a is. So negative 6 divided by negative 6 is 1. So these are going to just become 1a, which is what we want. And then 6 divided by negative 6 is also 1, but since one term is positive and one term is negative, it's a negative 1. So a should equal negative 1. Now we need to check our work. I'm going to scoot this over a little bit so we have some room. I'm going to substitute negative 1 into our original equation. We could substitute it into our simplified equation. It would work the same way. But I'm going to substitute it into our original equation, just because. So we have 2 times negative 1 plus 2 minus 8 times negative 1. And what do we have? And this should equal 8. Let's not put that over there. I'll scoot it over just a little more. Okay. So it should equal 8. 2 times negative 1 is negative 2 plus 2, because we didn't do anything to that term. And then negative 8 times negative 1 is going to be a plus 8. And all of this hopefully will equal 8. Now, just like before, if I have a negative 2 plus a positive 2, those terms are going to cancel out. Those are just going to become 0. And I'm left with 8 equaling 8, which is what I wanted. So, our solution, scooting this back over, of a equaling negative 1 must have been correct. So there we have it. We've gone over multiple examples of how to handle two-step and multi-step equations using distributive property, using combining like terms, and all of our inverse operations. Hopefully with this, we'll be ready to tackle anything that is in our way. Hope you've enjoyed the video, and good luck.